Hello and welcome to Saving Grace Homeschool. My name is Leanne Smith. Today we'll be covering the topic of construction of geometric figures. The first concept that we're dealing with is what is an angle. If we draw something like this where we label it A, B, and C. An angle is formed when the two lines AB and BC come together and meet at a common point. So B, which is called your vertex. So that point over there is called your vertex. The angle measures the amount of turning about a point in degrees. So if you start at line AB, it measures how much there is a change in degrees from going from AB to BC. When you name an angle, you name it as with the lines that are involved. So it's A, B, and C. So the angle is from A to B to C. And then the point where the vertex is, that has a little cap on the B. So the one with the cap always shows you where the vertex is, and the vertex is always written in the middle. Another way of writing out what an angle is, you write it the symbol to show an angle, and then you write A, B, and C, and this shows you again that the angle is at B. We're also going to be covering the topics of producing the lines. That's just extending the lines to be able to measure the angles a bit better, and the differences between parallel lines and perpendicular lines and how that affects your angles. A bit of background information about what angles are. If you look at this triangle over here, it is made up of three different lines. Between the one line and the second line, there is a distance. That is what an angle is, and it is always measured in degrees. So the angles of a triangle will add up to 180 degrees, for example. If you stand in one spot and you turn around completely until you end up in the same spot again, you have turned around by 360 degrees. So 360 degrees is the amount of degrees in a circle. You also call this a full turn or a revolution. The concept of angles is basically you move from the one point up until the next point by turning. So if you open a door, for example, it's initially closed, and then as you open it up slightly, that difference, so imagine this over here is a door where AB is your door initially. You move it to the position AC. It has moved by a certain amount of angles. Then you move it from AC to AD. Then you have moved it by further degrees. And in this case, the angle over here will be BAC. So if you look here, BAC, the vertex, which is your corner, has that little cap on it. And the angle over here is CAD, where A has got your cap. You can also have an angle, this whole angle, where it's from B to A to D, and A has got the cap on. So there's different ways of naming an angle depending on where it is by how many degrees it has turned by. There is a common misconception that if this angle takes up more space, then it means that it is larger. but the size of the angle does not depend on the length of these arms. So the arms is basically here where I'm pointing with the arrow. It doesn't depend on that. If you move let me just annotate. If you move something open, let's just stick by the concept of a door. Imagine you're moving a small door and you move it from that position to that position, okay? It moves by say 30 degrees. Compared to now, if you have to move a gate, which is a lot larger than a door, and it's a swinging gate. So imagine that the gate is a lot larger, but in the end, it still only moves by 30 degrees. So it does not depend on the arms that we are, or the length of the arms that we are looking at. A small and a large angle, which is shown here at 4.1, this is the difference between the two. A small angle has a much smaller area between the two arms over here compared to a big angle. If you draw connecting the two, that's a lot bigger than that small little area over there. So basically, the larger the angle is, then it has the directions between this arrow and that arrow are a lot further apart. Whereas at this small angle, the directions are almost identical. We have certain words that we use to describe angles. This long parts over here, these long lines are called your arms, and that just shows the two lines that are at an angle to each other. So imagine it being a door. It was initially here, you swing it open, and now it's at that position. The point at which the arms meet is called your vertex, or the plural of a vertex is vertices. The arrows over here on your arms show that these lines keep on extending so that the length of the angle's arm does not change the size of the angle. When the arms are long or short, the angles always stays the same, so it has no effect on the size of the angles. The arc over here shows where the angle is. You can also label a angle, so you can label here with this arc. You can use a dot, or sometimes if there are many angles around one point, you would label it 1. So if we have like that, for example, so imagine this being a circle, and you're talking about that's the one angle, that's number 2, that's 3, 4, 5. So that when you speak of it, you can say angle 2, and then you know exactly which angle you are referring to. If something is at 90 degrees to each other, it's labeled by this little box over here. It's also called a right angle. Yeah, it's just a revision activity just to make sure that everyone is on the same page. So just once again to highlight that a angle is the amount that you have turned by. So number 1, look at the drawing on the right. Are these lines at an angle to each other? So yes, they are at an angle to each other. Do the lines have to meet to be at an angle? No, they don't. So an angle just means that they are not, that there is a slight turning point between the two, even though they're not meeting. If we would have to put a ruler on this line and extend it, so let me just draw that. If I had to put a ruler on this line and extend it, and a ruler on this line and extend it, you would see that eventually they will cross and you will be sitting with an angle. When extending lines, it's very important that you put the ruler directly on the line, because just a slight difference could really affect your answer. So they are at an angle to each other, even though they are not meeting. Then it says, copy the lines. You have pencil on your ruler to draw the lines a bit longer so they meet. Oh, so you see, that's exactly what I did. And then, did you change the angle between the lines when you extended them? No, you did not. All that you did was just now show the angle that exists. You just showed it visually, but it's still the same line at the end of the day. And so they're still at the same angle to each other. Okay, looking at number 2, we have to arrange the angles from biggest to smallest. So the biggest one will always be the one that has the larger turning distance. So if you look at D, that is like a big one, as you can see. So D will be the largest, and then here will be E. E is just slightly smaller than D, so the amount of turning about a point is a bit less for E. So this will be number 1. This will be number 2. Afterwards, then we are looking at, you see, this angle is a right, or we think, okay, it's not a right angle, but it's very close to a right angle. This angle has started to go in a bit. So these are acute and obtuse. So acute angles will always be smaller than obtuse angles. Obtuse angles are greater than 90 degrees. A right angle is 90 degrees and an acute angle is less than 90 degrees. So for this one, this will be number 3. All right, now for these ones. This one is just slightly off of 90 degrees, so that will be your next one. And then compare A and F. F is definitely the smallest angle, so this will be number 5, and this will be number 6. All right, 3. How can you check that an angle is a right angle without using any special mathematical equipment? So without using a protractor. With this, you can use anything that is a square or a rectangle, because if I have to just continue with this one and make it a rectangle, all of its angles are 90 degrees. So if you think about an object that is 90 degrees, it is a piece of paper, for example. You can use a piece of paper, you can use basically anything that is a square piece of paper, a book, your ruler sometimes. Well, if your ruler is completely, if it's not like curved on the sides, you can use your ruler. Okay, number 4. Are these two angles the same size? The size. Describe how you found your answer. Hint, a piece of scrap paper may help you. All right. So you can use a piece of paper and cut it out along these lines. Then you'll take that piece of paper, place it above this one, and then if it matches directly, it will be the same size. If it's smaller, then you know it's smaller angle over here, and if it's larger, it'll be a larger angle. Number 5. These two lines are drawn by holding down a ruler and drawing lines on both sides. What can you say about the lines? So these lines will be parallel to each other, meaning that the distance between every point on those lines is identical. So the distance between yeah and yeah and yeah and yeah are always, say, maybe like 2 centimeters right throughout those lines. Also, these lines never touch. That is what parallel lines are all about. They never touch and the distance are always the same. So if you continue this to, say, infinity like we did here, you just keep on extending it. They will never touch, so there isn't an angle between them. Number 6, look at the analog clock face on the next page. The minute hand and the hour hand make an angle. Okay, so focus on the smaller angle for now. All right, let's go have a look at that. Okay, so here is that hour hand. Question A. Explain why the angle between the hands at 8 o'clock is the same size as the angle at 4 o'clock. Okay, so if I have to go and draw that, right? You have your one angle like that, and you have your other angle like that. Between 12 and 11, you have traveled 30 degrees because in a circle there is a total of 360 degrees and there are 12 points to consider. So it's 360 degrees divided by 12, which is 30 degrees. So moving from your 12 to your 8, that's 3, 6, 9, 12, that's 120 degrees. It's the same as moving to the right, 3, 6, 9, 12, 120 degrees. So they are identical. Okay, B, compare the angle at 2 o'clock. So let's just do that. We are comparing the angle at 2 o'clock with the angle at 4 o'clock. What do you notice? Okay, so the degrees between the 12 and the 2 is 60 degrees because of that 2 jumps. And the angle between the 12 and the 4 is 120 degrees. So we notice that the angle between at 2 o'clock is half the angle at 4 o'clock. Okay, then C, is the angle at 3 o'clock the same as the angle at a quarter past 12? So that is what we are dealing with. Sorry, I read the question wrong. We are dealing with, let's just do this again, as the angle at quarter past 12. So that's a quarter past 12. And the angle at 3 o'clock. So at 3 o'clock, it will be, so that's at 3 o'clock and a quarter past. This hour second hand would have moved a bit. So no, it won't be the same because when it's at 3 o'clock, it is dead on the 12 and dead on the 3. Whereas if it's at quarter past 12, that hand would have moved. Okay, so this is 3 o'clock, dead on the 12, dead on the 3. At quarter past 12, you've got the hour hand just slightly off of the 12, and you got the minute hand on the 3. So it'll just, because of that slight difference, it won't be the same angle. Okay, and then we have number 7. When you open the cover of a hardcover book, you can make different angles. Can you think of at least 5 other situations in everyday life where objects are turned through angles? All right, so if we look at the answer here, number 7, it's basically anything that can open. You can open a door, your laptop screen, a CD cover, um, your arms and your body, and your arm, just your upper arm and your lower arm, with your vertex and your elbow. So like there, your vertex will be your elbow, whereas here, this could be your shoulder. So it really, anything that can open up will be an acceptable answer where you can identify what the vertex will be. For example, like the door, the vertex will be the hinges. Like everything else, there is a unit to measure. So if you want to measure the length, it can be anything from millimeters, centimeters, meters, kilometers, and so onwards, because we need this to, for example, design buildings or any structure, even just doing your laptop, all of that needs to have a certain degree or a certain measurement. Now, for your angles, the unit for measuring it is your degrees. It has been decided that in a circle there is 360 equal parts. So you say in a circle there is 360 degrees. Now, if you go and cut it up into quarters, each quarter will be 90 degrees. And there is a special name for this. You call it a right angle. So this, I'm going to make this number 1. And if we look at the table, that is number 1. That is your right angle. It's very important. Then if you cut a circle in half, you get 180 degrees. This is called a straight angle, and I'm sure you can see why. It is literally just a straight line going through your circle. A revolution is your 360 degrees, so that is a full turn. Then we have half a right angle. So if number 1 was our right angle, half of it would be number 3 over here, and that is 45 degrees. Then you get a third of a right angle, which is 30 degrees, because a right angle is 90. If you split that into 3, you'll get 30. So this is number 4 and number 4. The same if you do a quarter of a right angle, you just split that 90 degrees into 4. Okay, and then that's just how you continue. Half a straight angle is the same as saying a right angle, but we usually use the term right angle. We don't say half a straight angle normally. Then 3/4 of a revolution. This is the case over here by number 5. So a revolution will be right around the circle, but now you've only gone 3/4 of the way. And a third of a revolution will be here, number 6. And that is 120 degrees. Okay, now we are looking at this activity. Number 2, look at the clock shown. How many degrees does the minute hand move in an hour? In an hour, it moves right around the clock. So it is then a full revolution, which is 360 degrees. How much does the hour hand move in an hour? So it's the minute hand that goes right around, but your hour goes from from 4 to 5. So if you remember previously, I said to go from the one part to the other part, it's 30 degrees because there are 12 equal parts, and in a circle there are 360 degrees. Okay, number 3. In grade 6, you learned that angles are classified into types. Copy and complete the table. Okay, so an acute angle is less than 90 degrees, so it is between 0 and 90. A right angle is 90 degrees. An obtuse angle is between 90 and 180. A straight angle is 180. A reflex angle is between 180 and 360. And a revolution is 360 degrees. So note here with your reflexed angle, you would write it on the outside part. So looking over here, this will be an acute, a right, an obtuse, a straight. You see, the reflex is this part over here. So you go in and put that little curve, that arc on the where the angles actually is. So it's not on the inside here, it's on that outside. Then the revolution is right a round. Okay, now this activity over here, you need a sheet of A4 paper. At the corners, you have 4 right angles. Number them and tear the corners off as shown in the diagram. Do not make them too small. Now use your right angles to investigate the following statements. Show that the straight angle is 2 right angles. So you'll take maybe like 1 and 4 and you'll put this 4 on that edge over there to show that it is. So actually with this activity, you can do it on your own and just, it's an investigation just to visually see what we are busy showing. There is an instrument that we can use to measure angles. It is called your protractor. So how this works is, this is what a protractor looks like. It has 180 degrees, so it's the same as a semicircle. You will put this circle on the vertex of your angle. Then over here is your baseline. You will put your baseline onto one of your arms. Then you will follow the degrees up to where the second arm is, and you will measure how many degrees that is. So if you have an angle like this, say that is your angle. You will go and put this circle here, the origin, that circle. You will put it over here, and your protractor must line up directly. I can't draw it that accurately, but it needs to line up directly on that line. It needs to overlap, otherwise it's not going to be accurate. Then you'll notice on your protractor there are, on the one side it starts from 0, like here, on the inner side it starts from 0, and here on the outer side it starts from 0. We are measuring this way. So your protractor is going to go like this. You choose 0 from where your first arm is. So in this case, if we look at this picture, it will be on the inner side. But now you will notice that you can't read it accurately because this arm isn't touching your protractor. So you go put your ruler on this one and you extend it until it crosses. That point that it crosses, you read as a degree. It might be, say, 73 degrees. If your, let me just, if your angle looked like this, you will go and put your origin of your protractor there and do your protractor like that. But now, because we are starting on this side, you'll read 0 from this point onwards, and that'll be on the outer side. So that 0 just depends on where you want to, or where your angle is situated. And that is how to use a protractor. And just always remember that if your one arm doesn't reach the protractor, just draw a line and extend it, but try to make it as accurately as possible. So if we look here at this image below, here on the left hand side, that is not aligned perfectly, so you won't get the same angle. This one is lined up perfectly, and you just want to go extend it like that. In the previous one, we showed how you line up your ruler with the line and you extend it. So over here you can see you place the origin on the vertex, and then you'll read it from that way onwards, and then the point that it crosses, that will be its degrees. This is, you don't want to do this because you see it is not aligned properly, whereas this is exactly on top of the vertex and the baseline is exactly on top of the arm. You can, it's not always that you will measure it straight like this. Sometimes you might need to turn your protractor around because your angle can be in different places. That is fine. Place your protractor according to where the angle is. And over here, just extend that line further so you can place the protractor directly on it. Here is just what I've already mentioned before, just how to do it. So now with this activity, you need to go and practice it yourself. You will place the origin over here and you will extend this line using a ruler. You'll place a protractor above it like that. And you see here where it says M. M will be here on the vertex, and you will, because this, you see here the inner side 0, 10, 20. This will be 0, and then you will see at what point it ends, at what point this line cuts the protractor. Say it is maybe 50 degrees. And then you do the same over here, you extend the line. For this one, see, you extend the line this way. You might have to extend this line as well. Please, you need to use your ruler. And in this case, you will start using this scale here where it's 0. So if you look here on the left, it's going that way. So that might be like 89 degrees. So use your ruler to be able to do this activity. Here is just some more to try. And then here is the sizes of the angles, so you can actually go and try for yourself. Just to make sure how close you are, it really needs to be really close with no room for error. It might be fine if there's 1 degree difference. So for this one, 42 and 44 maybe, but it really should be accurate. You have your protractor is normally found in the math set. So with that, I don't see why you won't be able to get the same answers. Also, when you use your ruler, make sure when you use your pencil, make sure it is sharp because that will definitely affect it. Okay, over here to measure it, you see this is a whole bunch of twisting and turning to be able to get the sizes of your angles. Just to give you an idea about how to maybe position your protractor. Here's the vertex, so you'll put your protractor, you'll extend this line. Do it in pencil so that you can erase it as you go along as you move from the one angle to the next angle. This is your vertex, say this is your protractor. You'll read yeah from 0, and then yeah will be 48 degrees as they have shown in the answers. So yeah, that's your. If you want to measure number 5, for example, you can see the line is already there. You place your protractor there. This should be your origin. I didn't draw it that well. And then you measure from this point up until that point. And yeah, number 10 also, you measure it, you extend this line, you draw your protractor, and then you measure it from this point to that point. For number 8, if it's a reflex angle, measure the inside first and then subtract that from 360 degrees. So say yeah, it was number 8, they gave you a value of 268. If you had gone and measured over here where I did it with the red, you would have gotten an answer of 92. So then just say 360 degrees minus 92. We have covered so far measuring the angles, but now sometimes they can give you an angle and ask you to construct it, which is like over here number 3, the activity over here. So how to do this, which is described in steps 2, you will first draw your baseline and you would mark your vertex. You will place your protractor with its baseline on this line and its origin exactly on top of this mark that you have made. So imagine this as the protractor, and that is the line. You will then have your protractor. It will go around like this, and then you'll see the different values going up. And then if you want to do 23 degrees, you notice that over here, it's 23 degrees. So with a sharp pencil on that 23, you just make a dot. A small dot. Then, let me just make it bigger so you can actually see. You'll do it a lot smaller. I'm just making it bigger so you can see it. Then once again, with a sharp pencil, you'll take your ruler and you will connect the dots. As you can see over here, here's the answers to number 3. So you see it always starts at the same origin. And then if you want to do 45 degrees, you place your protractor on this line with the origin on the mark that you've made. You'll look for 45 degrees, you'll make a little dot there, and you will connect the dots. Okay, I missed it completely, but you'll use a ruler to try and connect the dots. And this line that we have been given is called a reference line. So this over here is called your reference line. Okay, then we have parallel and perpendicular lines. I've already mentioned the concept of parallel lines. So parallel lines is when they never meet each other. There is never an angle between them. And the distance between, say, P and R is the distance, oh, actually, no, they aren't exactly straight. But the distance between the one line and the next line and the one line and the next line, no matter at which point of the lines you take, they will always have the same distance between the lines. And you show that lines are parallel by using these symbols. When you, so it's the arrows, the arrowheads. and you'll usually place it on the middle. So they've done it for you. I didn't want to go over it. So you place it on the middle of the lines to show that they are parallel to each other. And when writing it, you say PQ. So you label the line with 2 points that you have found on the line. And then you put a dot, a line and a line. That makes sense. That's exactly what parallel lines are. And then you say RS. So by seeing that, you know that PQ is parallel to RS. Now when it comes to perpendicular lines, they are at 90 degrees to each other. So they form a right angle. And when you write it out, you write basically what you see. You see line AB, then you see it forms it forms that shape. And that is exactly the symbol that you are going to be using when saying that AB is perpendicular to BC. So perpendicular lines have a 90-degree angle between the two lines, and parallel lines have the same distance between the lines, and they don't have any angle between them. All right, so, well, I can't say they don't have any angle between them, but they never meet each other. Okay, that is basically the difference between parallel and perpendicular. Okay, so number one, we want to draw a line that is parallel to XQ and that passes through point A. So the first step is to draw a perpendicular line between A and AX. So you'll go from A, well, you would take your protractor, you will measure 90 degrees to A using XY as your baseline. And then you measure, so you just then draw a straight line going down. Then you will do the same for another point. So you see, I've done the same where I've taken XY as my baseline, and I have drawn, okay, yeah, so this is my first one. Then I take XY as my baseline again. I measure 90 degrees, and then you know that that line and that line are parallel to each other. Okay, so once you have drawn those two lines that have equal distances, so you'll go measure 90 degrees to draw the red line, you'll measure 90 degrees to draw the blue line, and then you see, okay, the distance between A and C is maybe 3 centimeters. Then you will extend this line so that it's also 3 centimeters. Draw a dot. At that dot, you now draw another line. So then this line, the black line over there that you have drawn, and your baseline are parallel to each other. All right, now there is a way to draw a circle with a string. What you'll do is it's all described here in this activity over here. You will take 2 pencils. Okay, so I've got 2 pencils like that. Not the greatest pencils, okay? And then you're going to go and have a string that is connected from the one to the other. Then what you do is you keep the one pencil constant. So you keep it fixed on, say, your piece of paper or whatever. Then you're going to stretch the string as far as possible and then move the circle around like that, and it should form a circle. Okay, so you keep the one pencil in the middle and you're just moving the other one around in a circle by keeping the string stretched the whole time. And just to recap quickly the properties of or just some words of a circle. If this is the center of a circle, from the one point of a circle, so one point of the circumference. Okay, so circumference is the perimeter of a circle. So that is the distance around your circle. That is your circumference. Then going from your one point through the middle to another point, and if that's a straight line, that is called a diameter. A radius is from this point to the side. So a diameter should be double the length of your radius, because the radius is only from the circumference to the circle, to the center, whereas a radius is from the outside to the center to the outside again. All right, so this distance so basically a diameter is cutting the circle in half while it goes through the center. That's your diameter, and your radius is from the center to your circumference. Okay, so that activity of a pencil is basically a way to show how a compass works. A compass is also found in your math set. So with this one, you know how you had two pencils and you kept the one fixed and you just moved the other one at a certain distance? This is now the same as a compass, where this point over here, that is the one that you're going to keep fixed into your piece of paper. So that is that is the point that is forming the center of your circle. You will then measure a distance from the one point to the next point. If you want a radius of 3 centimeters, you need to make sure that from this one tip to this tip over here, that it is 3 centimeters. After that, you keep this side fixed into your piece of paper, and you're going to use the handle over here and you're going to swing the compass around. As you swing it around, this pencil is going to draw. Okay, wait. So this is the part that, as you can see by the pink, that's what's forming our center of our circle. So this is on a bird's eye view. This, you keep it fixed. Then you're going to turn the handle. Here is where where the pencil is. As you turn the handle, the pencil is going to move around like that. And if you measured a radius of 3, the distance over there will be 3, the distance over here will be 3. So at any point from the center of the circle to the circumference, the distance will be 3. It can get I won't say tricky, but it can be it can get some getting used to be able to do this. So I suggest that you practice using a compass. And then also when you measure, if you want a radius of 3, measure this distance, and then afterwards check if your ruler, once the circle is drawn, to make sure that you actually achieved that. Okay, oh yeah, is a very nice one where they can show you exactly how it is done when you use a compass. So as you can see here, they've measured the distance to be 2 centimeters. Then they hold this section over here fixed, and then you just move the pencil around. As the pencil is moved around, it forms the circle. So then over here, your radius will be 2. You can repeat it again to get 3, to get 4, 5, and 6, and so forth. So it's really quite nice to make. Sometimes you can get overlapping circles, as you'll see here later, and it's really nice. So what you have drawn this is called concentric circles. Concentric circles all have the same midpoint. You see, um, they all these circles 2, 3, 4, 5, 6. They share the midpoint of A. So here's where you can actually draw some pretty circles in the end. Where you have your main circle, which is the yellow one, and then from that point you can draw another one, and then so let me see if I can. So this will be your main circle. From that you draw another circle over here, and then another circle like that. So you see, and then you just keep on drawing the circles so that they overlap together. So this activity over here is to be able to construct this, and there they say that you must make the radius to 4 centimeters, draw a circle at the center. Yes, so that is your first step, and your radius must stay the same for the whole activity. So the radius from this point to that point must be 4. The radius from this point to that point must be 4. So you're keeping it constant the whole time. Okay, so now you put your compass point anywhere on the circle page, and then you draw another circle, and then the circle should pass through the center of your first circle like you saw previously, so that they can have the same radius. So over here, you let me just get rid of these lines. You first drew your circle, then that one at that radius is where your new circle is going to start. Okay, so your first step is like this. You first draw your circle, you find its radius, and then that is where the second circle starts, and then that is where the third circle starts, and so forth. And then that is how you're going to overlap it like this. So drawing or doing this activity wasn't a complete waste of time, because what it helped you now do is to be able to draw different polygons. So the one that pops up is, if you at this point where the circles meet, you draw a dot, and if you connect these dots, obviously using a ruler so it's not as skew as mine, you would have created a hexagon. You can also have where you join 3 of the dots to get a triangle. You can have, that was a bad start, let me try again. So doing it like this, you get a square. You can also have, if you want, a pentagon, for example. Like that. And so you just keep on going. So that's just different ways of how you can identify your different polygons in this. I'll now be introducing the concept of an arc. So you have a circumference, which is the distance around a circle. A arc is now just a section of that circumference. So if you look over here, so arc can be the full distance, but usually we use it to refer to a smaller part of the circumference. So this will be an arc. These are all arcs. This one's a bit smaller than that one. This one's nearly the full distance. This one is just more than a semicircle, and this is a quarter circle. So if they ask you like, yeah, draw an arc using a radius of 3 centimeters. This is now whenever it's circles and they ask you to draw, you need to use a compass. So what you'll do is you'll take your compass, you'll measure out 3 centimeters between that fixed point and your pencil. And then, so your fixed point will be fixed into your page over there. And then you just use your pencil to draw an arc like that, where the radius, as you can see over number 1, the radius will be 3 centimeters. So it's very important to make sure that you measure the distance between that fixed point that goes into the page and the pencil accurately. Then the rest of the activity is also just doing it with 5 centimeters, where the one is just bigger than the other. So the one is bigger than a quarter circle, and then the one is smaller than a quarter circle. So remember, a quarter circle is 90 degrees. All right, so on the left hand side here, we have different images, well, different designs of circles that you can try to copy and then just see. This is good practice when using a compass. There's also a bit more challenging ones if you want to try. And number 2, where it shows you exactly how to draw it, like this one over here, the blue one. It shows you exactly how to draw it. Then this red one's also really good practice as well. But yeah, see if you can try the differences between these ones. So to get these circles perfectly, the radius of the red one, you're going to have to half it to get the yellow one. So let me just show you. So if we have, that is the radius of the red circle, say it is 2 centimeters, then to draw the yellow one, it's going to have to be 1 centimeter. That's just how to draw that one. It's the same here with this yellow one. And then on this is similar to what we did previously, where you first start with that center circle and then you draw the other 1, 2, 3, 4, 5, 6 circles connecting it. So this is a 7 circles over here. So then you just draw it starting from the radius of the other one and drawing it across like that. Then you connect the dots and then to form different polygons like we noticed previously, where we could get that hexagon, which is shown over here, where it's 6 sides and all the sides were equal, as well as now all the angles are equal. With an equilateral triangle, so an equilateral triangle is drawing it like that. That is also all the sides are equal, and all the sides are equal. They add up to 60 degrees. A rectangle you can draw from like that, where all the angles there are 90 degrees and the opposite lengths are equal. A trapezium is just a 4-sided figure. So it has like that will probably be a trapezium, where it has 2 obtuse angles and 2 acute angles. And one side is, actually no, that is not a trapezium. A trapezium would be it needs to be parallel sides. So you'll connect that and that. That is your parallel. And then you would connect that and that. Here is your obtuse angles. And here is your acute angles. And then a kite is the one that I drew previously, where the adjacent sides are equal in length and one pair of angles are equal in size. Here is just an activity where it shows you step by step how to draw it. So for example, for 1A, it says that you must draw a line first, and then this line should be 3 centimeters and 6 centimeters. It should be between 3 centimeters and 6 centimeters long. Draw it in the middle of your page. So this will be A and B. You will label it as A and B. Then you have to set your compass to where A is the center, and then you use your ruler from B. The pencil part of your compass from B, and you make a circle. Then you set that fixed point of your compass on B, and you make a circle again. And then the point that they cross, so they cross there, and they also cross at the bottom. You can choose the point. You label it as C, and then you connect the dots from A to C and C to B. And then it asks what type of figure is it? It is a triangle, an equilateral triangle, and they want to know why it is so. And that's because the distance from A to B is the same as A to C, because that's the radius of a triangle. The radius of the circle, and the distance from A to B and B to C is identical because that's the radius of that circle, and both circles are identical, meaning that their radii will be the same. For number 2, it shows you here step by step how to draw it as well. So step A, step B, C, and D. Alright, this is just parallel and perpendicular lines with circles. The first question, 1A, when one line is parallel to another line, the lines. So with parallel lines, you know that they have always the same distance between them, and they will also never meet each other. Then for 1B, when one line is perpendicular to another line, this is when the lines are at right angles to each other. So they meet at right angles. Okay, for number 2, you have to copy this again, and then you draw the dots at the point where the circles intersect. Then you have to show, so intersect just means where two lines cross each other. And then you have to show where they are parallel. So all of this is parallel, that's parallel, that's parallel. So you see anything that's parallel, and then let me just mark it for you. So this could be, oh, that was bad. Give me a second. That's parallel to that, for example, and then we could have that this and this is perpendicular to each other. Okay, then for 3, draw a few circles with the same radius along a line, so just keep on going. Start by drawing a line, and then use your compass to draw a circle with the midpoint of the line. So you draw your hang on, you draw the one circle. After that, you find its midpoint, and that's going to be the starting point of your next circle. Then you find that midpoint, and that's going to be the starting point of your next circle, and then so onwards. This is just further activities where you have to construct lines. For this one, it would be you use the circles to construct a line that is perpendicular to the line below. So To do the perpendicular, you draw the two lines, the two circles are crossing that line, and that line has to cross the center. And then the point at which the circles intersect, you would draw a line through those circles, and then that line will be perpendicular to your original line. The same now, if you want to draw parallel lines, you draw your circles. Again, the one circle starts at the center of the next circle, and then your perpendicular line, your parallel line will be again through where they intersect. And then that's how you would do that. And that is everything on geometry. Goodbye.